Hi everyone. Let's take a look at number 7 on page 91. Determine the point or points where the tangent to the curve is horizontal. Now before we start with part B, again, the first thing we want to think about is a horizontal line. So just in case, if you forgot, a horizontal line goes from left to right. A vertical line goes from top to bottom. So again, when you think about a horizontal line, the first thing you want to think about, which ideally was taught back in grade 9, is the idea of slope. So there are 4 cases when it comes to slope. Sometimes the slope is positive, negative, 0, or no slope. And if you have a horizontal line, the slope is going to be exactly 0, also known as a 0 slope. So again, horizontal line, 0 slope. Now, if you look at the function y equals to x squared plus 2x plus 1 times itself, you could expand this to 9 different terms and use the power rule. Now, personally, I think that's suboptimal. The more effective method, or the optimal method, is to rewrite this. First of all, you can rewrite this by collecting like terms, or in factor form, x squared plus 2x plus 1 to the power of 2. Now, can I apply the chain rule and find a derivative? Yes, but again, what you should do, I think, is to factor this a little bit more. So what I mean is, if you think about the brackets out here, that's still going to be quantity squared. But if I highlight x squared plus 2x plus 1, that on its own, it's a perfect square. So again, that's going to be x plus 1, quantity squared, square. And of course, if you think about the exponent law, power to a power means you multiply. That's going to be x plus 1 to the power of 4. So 2 times 2, that's going to give you 4. Now, we can find the derivative, which is y prime, apply the chain rule, bring the 4 to the front, copy x plus 1 to the power of 3, multiply by the internal derivative, which is 1, and set the general slope, gs, to the specific slope, ss. So again, you set the general slope to the specific slope, and you solve for x. Now, if you look at this carefully, the shortcut is x is going to be -1. Now, in assuming for you, this is the optical illusion that it looks simpler. I'm just zooming in. Now, you could say x equals to -1, but in case you're not sure how that is the case, let's divide both sides by 4. So again, the opposite of multiplying is to divide, and in this case, 0 equals to x plus 1 quantity cube. The opposite of cubing one side is to take the cube root, just like that. Now, unlike a square root, there's only one case. So when you take the cube root, there's one case. 0 equals to x plus 1. This means x equals to -1. That is not the final answer yet. Again, you want to go back. The question is asking specifically for the point or points. So you have to go back, plug it in to find the corresponding y value. So I'm going to take this, plug it back to here. This means the corresponding y value is going to be -1 plus 1 to the power of 4. And that's going to be y equal to 0. This means xy equals to -1, 0. Now, just in case you're thinking, I did this question, but I'm not super confident, how do I know for sure I'm doing it right? So let's over-deliver. I'm going to draw a graph with you. This is a way to double-check your work, and now you know for sure you're doing it right. So I'm graphing y equal to x plus 1 to the power of 4. And again, if you think about this, here's the graph. So I go back. Let's use a different color here. My goal is to graph y equal to x plus 1 to the power of 4. If I look at the x-intercept, that's going to be -1. I look at the y-intercept, that's going to be 1. So it's going to look, roughly speaking, something like this. And if I use a different color, and I'm graphing a horizontal line at y equal to 0, you will discover that this point right here is So negative 1, 0. So again, now you've double checked that this point, negative 1, 0, is going to be a tangent to this curve, which makes it horizontal. I hope this makes sense.